So the problem that was obvious to me in one time and is not anymore, if serendipity is a mechanical phenomenon, i.e., can it be implemented in a Turing machine? The first obvious answer is, of course not, because if it's programmed, then serendipity is not there anymore. But then, going on with this big data, machine learning, deep machine learning, I said, oh my God, is it true that we cannot really go on this? And so I'm not certain about the answer of this problem, and I'm going to discuss this in 3 steps. First, I will just summarize what Mariana presented. She cleaned up my path, and I thank for that. Talk about serendipity as a special case in science of second-order abductive reasoning and mechanical models of intelligence. Then I go on serendipity and wisdom. It's a difficult concept and complex system thinking, and I'm going to end up by bringing a problem about challenge from the complex system perspective on serendipity in science in the 21st century. So for the first part then, what can we say about serendipity? I just assume, inspired by Samantha's paper, that the concept, we're operating at the level of concept, not of the event in itself. So I assume that the characterization of the concept of serendipity as a category used to describe unexpected discovery in science that involves chance and wisdom. And then, inspired by Peck, I just focus on the type of serendipity as a second-order meta-abduction in science. And then I thought, if we go a little bit further on this hypothesis, what could complex system thinking offer to us to add to what is already done? And so let's go on for the serendipity and abductive reasoning. As Mariana introduced you, one version of Peirce's abduction is that we are confronted with the problem. For instance, I have this problem. Is it a mechanical or is not a mechanical serendipity? And we go on thinking about that in 4 steps for Peirce. First, there is the observation of this anomaly or problem. And then we search for hypotheses for the purpose of explaining the anomaly. And then if we find, we may not find, keep the whole life as I'm almost given up to have the answer to my problem. Maybe we never end up with the hypothesis, but in case we do, we have at the logical level, the deductive confirmation of this hypothesis that would predict the original anomaly. And then the important point is the inductive testing, as Mariana stressed, because we have to have data in the world to confirm the hypothesis. And it is in this stage of inductive reasoning, when we go on in the world, that serendipity might happen with this inductive testing of hypothesis. When it's taking place, then by chance, and that's, I would like to talk again with Peck about the role of chance, scientists would find some unusual fact, initiating then a second-order abduction. So it leaves a little bit aside the first problem, the first induction, and go on in the second-order abduction. Now is a different problem. We are going on trying to find an explanation for this unusual event. And in this sense, we agree with Samantha that there are various variations of serendipity. We can, that's common sense, science, but even in domain of science, the process of serendipity discovery can be complex. So if we find some interesting event there, then serendipity is retrospectively categorized, and the primus of the epistemic expectation is elucidated. So the question is that it seems that we have an algorithm via abduction. So can this abductive reasoning of second order or any order, third, fourth, and conceptual reasoning be mechanical? That's torturing me, this question. What is mechanical? It can be put in a kind of algorithm and running a Turing machine. In the early 90s, we had this classical paper by Creativity and Margaret Bowden, and she claimed that yes, machine can realize discovered, and she gives the algorithm in a way, saying that we deal with conceptual space that are multidimensional informational structures that are organized with principles that unify a domain of action. So the key word here is principle that unify the domain. And what are those principles? She says is the generative systems that underlies the domain and defines a certain range of possibilities. So in the early 90s, these principles are given to the machines, and they are still given, but in a different way. So I brought to you here this astonishing phenomenon for me, that is the meaning generator systems. And I'm asking if this is a mechanical creativity. What happens? Working with computers, we know that in general, computer operates at the syntactic level. There is no meaning in information. And so that's John Searle's and everybody's critics on AI, that there is no meaning behind it. But now this machine proposed by Menand can generate meaning. And what is the meaning? So it says the generated meaning is the connection that exists between the received information and certain constraints. So the machine has initially a small kind of constraints. And the generate meaning is to trigger an action, and that's the important point, aimed at satisfying that constraints. So the machine is involved into the environment, and the point is that the action will modify the environment, and so the generated meaning. So it's a kind of affordance, a meaningful information that is updated. So it says meaning generation links agents to their environment in a dynamic mode. And he got what I always feared, that these people in AI would be good in semiotics, in person semiotics. Then the machine would leave the stage of Margaret Bowden to go to something much, much more complex. So this mechanical machine can generate meaning by interacting with the environment and adjust it to action. So then the question of serendipity, is it any chance for serendipity there? Let's consider a case that the machine is trying to search for the meaning of a word in a certain corpus. And by chance, so here's chance as inverted comma, because we know there's no chance, real chance in computers, but it finds another strange world that doesn't fit the previous experience. So it will start a kind of abductive reasoning, and then it could find something else that would then be explained later on. And so if that is the case, do we have a case of serendipity there? no surprise, it was just anomaly detection, no subjective element, but still some sort of mechanical, not very simple type of discovery here with this meaningful generator. So just to summarize this part, we say that computer models might exhibit creativity in the Margaret Bowden early stage by exploring and transforming conceptual space. Now, with abductive reasoning, exploration in conceptual space may lead to mechanical kinds of creativity. So far, okay. Now, with machine learning in the 21st century, deep learning, the process of serendipitous discovery so far can be simulated. I wouldn't say that it can be experienced, and then retrospectively characterized. But the question is that what is missing there? Why can only be simulated and not the real experience? For me, I don't know what feelings are, and when you see this Sophie robot trying to confuse people's perception and all this work on AI and emotion, I think we should look at the notion of wisdom. It seems that what is missing there is wisdom. But what is wisdom? So we go on to the second part, and serendipity, wisdom, and complex system thinking. It's our hypothesis that the experience of serendipity involves sagacity and social complex systemic thinking, but above all, a good serendipity would involve wisdom. And we have here the experience with Peck and everybody else with this notion. So let's go back a little bit to 30 years ago. This very dear friend of us, unfortunately passed away, Marcelo Dascal. He says in the 90s that researchers in AI should direct the attention to the question of whether it is possible to develop systems which are not subordinate to the knowledge and to the rules and criteria that are supplied to them, ex machine. And if so, how? But the important point, he reminds us that they should not forget that this pragmatic aspect of knowledge derives from public social character of justification. So the public and the social element brings me back then to the complex system thinking. It seems that we have always trying to analyze event, in the case serendipity, at multiple scale. So as much as we can, we go to the micro and micro level. We focus on self-organization because it seems that we are nothing without the communication with our friends in our society. And it's not always the case that a central commander is there. Self-organization has a very deep power in our existence. And particularly the phenomenon of emergence, which results from the communication between parts of a systems in a very strange way that we don't know exactly how it operates, but it's not just the sum of parts. And then with circular causality, and I would prefer use the term, not just circular, but let's use circular for here, the whole process becomes more and more complex. So let's now, with this short approach to complex systems, see what happens with serendipity. So the systemic interdependence of these many layers of a networked society, and now we are giving a zoom to the context of a networked society. It's fundamental to help in the understanding of this serendipitous discovery, on my view. So with self-organization, circular causation, and emergence, this continuous generation of information and new types of meta-abduction and complex system, positive and negative serendipity might emerge. So this astute mind can produce some undesirable serendipitous event, indicating the need for wisdom in order to keep only the good ones. But what's this wisdom? So from a complex system perspective, I think it's very provisionary that wisdom may be understood as a kind of social collective intelligence that involves information and knowledge, and combined with the structure of the systemic thinking, we emerge, wisdom can emerge and might allow the emergence of the relevant good serendipity in science. So we have lots of data, especially with big data, and without a specific order organization, they are just noise. But when we have a kind of organized data, we have information. Information, when it has some correlation with events in the world, produce knowledge. And knowledge, when considered for well-being of existing creatures, not only humans, but living and environment, that may be producing wisdom. And then in a feedback way, we have new data, selection of data, information, knowledge, and wisdom. So back to our initial problem. Is a serendipity a mechanical phenomenon? To be honest, I don't know in the 21st century with all this new data. But what I know is that serendipity, the experience of serendipity, involves social systemic thinking, and the good ones involves also wisdom, which so far, at least, are absent in mechanical systems. If they can have feeling or not feeling, I don't know. But so far, because lack history, evolutionary history of errors, ignorance as presented before, errors, correcting errors, these mechanical systems don't have it so far. So for the, just to finish this and to leave you with some challenge, if we accept the possibility that serendipity could eventually in the future be experienced by machines that have machine learning, deep learning, and all these, then I think we need to have a complex system perspective to incorporate certain kinds of ethical background principle controlling this kind of research. And inspired by this wonderful paper by David Lockwood, that's called A New Approach to Rule Consequentialism, he suggested that AI could have these background principles that are higher order principles that reduce the numbers and the complexity of practice rules. So taking priority over individual practice rules. I assume that's kind of Zen way, says that put compassion in your action and act as you wish. I don't know what compassion is, but the point is that a small number of such principles could modify practice rules, particularly in AI, so as to yield many combinations indefinitely. So just going to present two of these principles. The first is that wisdom and systemic integration should be incorporated in serendipity research, so that ethical, social, cultural, political, ecological, and economical context should be, as much as we can, integrated and notice that they are codependent. And Pauline stresses understanding this context and their interwoven nature is critical in the effective use of data, information, and knowledge. I know it's just a little bit utopical, but utopias can be good at certain times of our life. But above all, responsible and intelligent serendipity is fundamental. So the aim of this complex system thinking is to act in order to produce the least possible uncertainty for responsible innovation. And the message I would like to leave for the young people and doing the research on serendipity, and that should be carefully guided with responsibility, so that we leave a kind of good inheritance for next generations, and so we can, as scientists and philosophers, give a little bit of our contribution to keep life going on.